Okay, so good afternoon. And my project is on title is analysis and performance of reliable integration between smart microgrid and the distribution network. Under the my guider is the Priya madam. So my name is Sonali. And those are the contents whatever I'm going to present. So microgrid is a small network with local source of supply which can be attached to external grid and also works independently. So microgrid with photovoltaic system and wind turbine system is considered with a certain DC to AC converters and the AC to DC converters. So electric power is maximized when voltage and currents are synchronized. So however, there may be times when voltage and currents have delays between their two alternating patterns. So here, a typical analysis model of microgrid containing wind power generation and photovoltaic generation is built and simulated based on the MATLAB Simulink software. So the wind and photovoltaic generation system, the basic block model of the wind and photovoltaic generation system. They're having so entire system comprises of PV and the wind system. So generally the PV system is powered by the solar energy, which is abundantly available in nature. So PV modules, maximum power point tracing systems, and the PV energy systems. So as the basic thing, the light incident on the PV cells is converted into electrical energy by the solar energy harvesting means. So a DC to AC to DC converter is used to convert AC voltage to DC voltage. And in wind turbine, wind generation system, here wind turbine and the gearbox, generator, and AC to DC converter are considered. So, a wind turbine is used to convert wind energy to the rotational mechanical energy, and this mechanical energy is available at the turbine shaft. So, is converted to electrical energy using a generator. So, the literature survey was made by the microgrid application in the rural areas of West China, and the some of the comparisons and some comparisons between the development ideas and the future directions are summarized. And here I have listed the 3 literature surveys. So next, going to the problem statement, safer and more reliable grid integration is the major issue. The safer and more reliable grid integration is restricting the further improvement of distributed power, which has become a significant issue. So electric power is maximized when voltage and current are synchronized. However, there may be times when voltage and currents have delays between their two alternating patterns. If they are out of synchronization, some of the power flowing through the circuit cannot be absorbed by connected devices, resulting in the reliability issues in integration. So the solution in this project is given as the microgrid system with photovoltaic and wind system is designed and simulated. So the output voltage of both systems are compared, analyzed to obtain same voltage, and the final reliable AC voltage is supplied to the external grid. So this is the block diagram that I'm considered for the simulation with a PV array with a closed loop converter and wind turbine with the AC to DC converter, and further it is converted to AC and given to the grid. So the basic block diagram of the photovoltaic energy system. This is the model, and so PV contains PV module, DC to DC converter, and the battery, MPPT, and the bidirectional battery. So DC to DC converter changes the level of voltage to match it with the electrical appliances. So the DC to DC converter may be either buck or boost, and here we are using the boost converter, boost converter. So the next is the wind power system. So wind power system, this is the block diagram, the basic block diagram, and it comprises of wind turbine, which transforms wind kinetic energy into rotating motion, and gearbox to match the turbine speed to generator speed, and the generator which converts mechanical energy into electrical energy. So as a basic rectifier which converts AC voltage to the DC voltage. So as per the block diagram, so PV array with the radiance of 1000 and the temperature of 25 degrees with the resistive load of 4 am simulated the PV array. So the output voltage you got as the 349.4 volts. Here we got the solar panel voltage, DC voltage, and the wind turbine simulation without this simulation without the converter. So here the pitch angle of 3 degree and the wind speed is considered 1000 meter per second with the resistive load of 10 ohm. And here we got the rotor speed as 234.4, and the voltage and the current waveforms of the wind turbine and the rotor speed of the wind turbine we have got, which are got in the AC. So the DC to DC converter with closed loop, which is used for the photovoltaic generation, where we are used here boost converter. So with the example of 15 volts, so the output we have got is the 33 to 18 volts. So this is the voltage waveform and the voltage we have got from the DC to DC converter with closed loop, and example of AC to DC converter. So here AC to DC converter with the resistive load of 10 ohm, and the voltage we have got as 317.8 volt. And so this is the waveform for the simulation of AC to DC converter. And the example of DC to AC converter, the voltage source we have given as the 24 volt input voltage, and we have got the output voltage as like this. And in this system, we are considering photovoltaic generation with the converter, DC to DC boost converter. So we can get the perfect DC output. This is the DC output with no variations. So voltage source of 28 volt in the input, and we got the 27.78 volt in the output. So the wind turbine with converter. So before examples are without converter, and these are considering with converters. So with converter, this is the voltage. So here the voltage we got from the wind turbine is AC voltage, and we are giving the AC voltage to the DC to DC converter, so you can get a DC voltage. So the final circuit diagram of the project is the PV array with the DC to DC closed loop converter and the wind turbine with the DC converter. So in the both we are converting the AC or DC voltage and is given to the inverter. So if the inverter converts DC voltage into the AC, so the final AC voltage is given to the grid, and in both the wind and PV array, the voltage is maintained same as. So the final output at the which is going to the grid is the AC voltage with 309 volt, and the current of 0.1 waveform is obtained. So the conclusion is as per the integration of PV array system and wind turbine system, the voltage made same at both the outputs, and the DC voltage is converted into AC output voltage and given to the external grid. Because of this, integrating of same voltage will provide required AC voltage and current, which makes the grid integration more reliable and flexible. Thank you.
Thank you very much, Sonali, for your presentation. Audience, do we have any question for this presentation, please? Thank you very much, Sonali. We don't have a question for you.
Okay, sir. Thank you.